Welcome to my YouTube channel Success Education Academy. Today we are going to start the fourth chapter, that is effects of electric current. So you know that electric current flows through the conducting material. So many of the types of metals you know that electric current flow through it, and how that electric current flow through the metal that already we have learned in the lower classes. So in this chapter we are going to learn about energy transfer in an electric circuit, then heating effect of electric current, magnetic effect of electric current, and some applications of magnetic effect of electric current. And in that we are going to learn about the electromagnetic induction, then electric motor and generator. So first that we are going to learn today is energy transfer in electric circuit. For this, to understand the energy transfer in electric circuit, we are going to use some material to understand this topic. So here we are going to take the cell. So there is a cell, and the cell, you know, it is having the two terminals, positive terminal and negative terminal. So positive terminal of the cell, the conducting wire is connected, and this conducting wire is cut down here to attach the switch. So plug switch we are using here in this circuit. So wire is connected to the resistance. Resistance, it is connected at point A and B. Then from B it is continued with the ammeter. So ammeter is connected, and again the supply is going back to the cell. In this way the electric circuit is completed here. So here at this point A and B there is a voltmeter. That is, we have to calculate the potential difference between the resistance. So here ammeter it is connected in a series to the resistor, and voltmeter it is connected parallel to the resistor to calculate the potential difference between the 2 points of the resistance. What happens here now? So when the electric current I flows through this conducting wire, when we plug in, when we switch on the button, so current will flow here and it will come at the point A. So current flows in the form of electric charge. So charge flows here through this wire and comes at the point A. Now resistance. Resistance is what? It is a resistor. Resistor is doing the resistance, means it resists the electric supply, or it opposes the flow of charge through that particular material in the resistance. So when it is applying a opposite force to the flow of charge, so it will be work done needed to flow the charge from this resistance. So that means work is done here to flow the charge. This resistance, you know, one of work is force into displacement. So here work is done in the form of force into displacement. So what is the force here? The force means it is applied a potential difference. So potential difference, so what we will take force as a potential difference. Now here this potential difference we are calculating at point A and B. So we say that it is a potential difference of A and B. So that is potential difference means volt of A and B. So force is applied by the potential difference on the voltage of the cell, and what is flowing? Displacement of charge through this resistance. So charge is given by Q. So work is equal to VAB into Q. So work is nothing but it is energy. You know that for doing any work energy is required. So work is done in the form of energy. Now you know there is a power. So power is what? It is a work done per unit time. So work done per unit time means W upon T, per unit time. So this work is nothing but it is an energy per time. And what is the work here? You have, it is equal to V into Q upon T. So in the ninth standard you have learned I is equal to, I is what? Current. Current is equal to charge per unit time. Charge means this is the electric charge, Q upon T. So we will utilize this I is equal to QT in this equation. So Q upon T you can see here. So instead of Q upon T we can take P is equal to PAB into R. So this is your first equation. Here we are obtaining some equation how energy transfer in electric circuit. So when there is a resistor, work is to be done to flow the charge from resistor, and this work is calculated in the form of V into Q. And what is the power required to do this work? That we are calculating, and we got that power is equal to VAB into I. So what we have to do in this equation? We know that when the energy is utilized to transfer from this resistor, definitely that energy is the electrical energy given by the cell, and this electrical energy is definitely going to be transformed into the some other form of energy, and that another form of energy is nothing but it is the heat. It will be generated here due to the energy applied to flow the charge from the resistor. So we have to calculate the heat. And what is the heat? It is nothing but it is a power into time. Means at how much time, if you are applying the power through the resistor, that amount of the heat will be produced. If lower is the time, lower will be heat produced, and if more is the time, power is passed through the resistor, more will be heat generated. So that is directly proportional to the power and time. If already you have the value for P, and that is from the equation 1. So heat will be equal to VAB into T. So that will be equation number 2. Now in 9th class again you have learned Ohm's law. According to Ohm's law, potential difference is equal to into R. So here potential difference we are taking in the form of AB, IR, and let it be your third equation. Now put this value of third equation in equation 2. So that will be equal to H is equal to, instead of V we will take IR. So I into T will be equal to heat is equal to I square R T, and this is your equation of heat. The effect of electric current passing through the resistor, that means the energy transfer in the electric circuit produces the heat, that is the heat effect of electric current, heating effect of the electric current. So that means heat is produced when the current passes through the circuit and passes through the resistor. So that what amount of heat is generated we calculate by using this formula, and this formula is called as a heat. Asked in the exam, state the equation for Joule's law of heat. So you have to do all the steps that we have done here. So this is the when an energy transfer in an electric circuit, heat is generated, and what amount of the heat is generated is given by this formula, and this formula is called as the Joule's law of heat. Now we are going to discuss about the unit of heat, and already you know that unit of heat is Joule. Unit of heat, that is H in joules. Then power, unit of power. So unit of power, already we have got an equation. What was that? VAB into R. So V, it's a volt. Potential difference is calculated in the volt, and current is calculated in the ampere. So 1 volt into 1 ampere, we can say that. And 1 volt means it is a 1 joule upon 1 coulomb. Coulomb is the unit of charge, and 1 ampere is nothing but it is a 1 coulomb per 1 second. So 1 coulomb goes cancel. So what is remain? 1 joule upon 1 second, and this 1 joule upon 1 second is nothing but it is a watt. So that is capital W. So what is the unit of power? Unit of power is watt. So I hope you understand energy transfer in electric circuit. So